In the vast expanse of space, there exist phenomena that continue to captivate our imaginations. Welcome, fellow explorers, to a journey into the mysteries of the cosmos. Today, we delve into the enigmatic and awe-inspiring world of black holes, as we uncover the latest discoveries and unveil the secrets that lie within. Join us as we embark on a cosmic adventure through the lens of 2023's cutting-edge research and understanding. Every year, scientists, educators, students, and space nerds around the world celebrate Black Hole Week. It's a chance for a little scientific levity, to contemplate the genuinely awe-inspiring forces at work near the very edges of the laws of physics, and to make dad-joke scientific puns. For Black Hole Week 2023, we've rounded up our best recent black hole news stories and our favorite facts about black holes from NASA and astronomers worldwide. Fluffy black hole. A few days ago, astronomers released all new images of M87, pronounced M87 star, a supermassive black hole at the heart of our neighboring galaxy, M87. M87* made history in 2019 when astronomers used it as the observation target for the truly gigantic Event Horizon Telescope project. But scientists adjusted the focus on their planet-sized telescope and tuned the image to pick up more of the fluffy, glowing, super-hot plasma falling into the black hole. Black holes. The coolest place you should never go. For educators, especially those teaching younger kids, NASA provided a helpful traveler's guide to black holes, sized just right for a spacesuit pocket. Naturally, it's important to start with safety guidelines, beginning with number 1: never visit a black hole. NGC 3489. The Hubble Space Telescope shows the black hole at the core of lenticular galaxy NGC 3489. NGC 3489 has an active galactic nucleus, or AGN. As the black hole devours material that gets too close to it, these ultra-bright radio sources emit radiation across the entire electromagnetic spectrum. This lenticular galaxy is a Seyfert galaxy, a class of galaxies whose AGNs are somewhat dimmer than those powering other types. Often, Seyfert galaxies have AGNs that don't outshine the rest of the galaxy, so the galaxy surrounding the black hole is clearly visible. NASA black hole experts chime in for Star Wars Day. As luck would have it, in 2023, Star Wars Day, May the 4th, not to be confused with Star Wars Day 2, Revenge of the 5th, falls in the middle of Black Hole Week. Sagittarius A*. Just a few years ago, an international team of scientists joined radio telescopes around the world to create a radio interferometer with an effective aperture the size of the planet. With that unprecedented observing power, they captured the first direct image of Sagittarius A*, the supermassive black hole at the center of our galaxy. We can't see the black hole itself. What we can see, though, is the infrared glow of the star stuff falling into it. The material SGRA* is consuming glows so brightly in part because it's moving very fast. So fast that the astronomers made a video of its eerily smooth motion, condensing movement on the scale of days down to individual frames. Centaurus A. The galaxy Centaurus A, Cen A, lies 12 million light-years from Earth, in the constellation Centaurus. In the center of this galaxy, the fifth brightest galaxy in the entire sky, is a supermassive black hole, shown here in the X-ray with jets of high-energy particles and other material. The jets reach about 13,000 light-years away from the black hole. There's also a dust lane around the middle of the galaxy, which may be the ancient remnant of a collision between Cen A and a smaller galaxy millions of years ago. A zillion tiny Big Bangs. This year, just in time for the party, astronomers posted a new paper on Preprint Server Archive, speculating that primordial black holes throughout deep time could have created their own tiny Big Bangs. Stephen Hawking determined that black holes emit an exotic type of radiation called virtual particles, the only thing that can escape a black hole. By way of these exotic particles, which we now call Hawking radiation, black holes will evaporate, eventually. In the paper, the authors remark that Hawking radiation emanating from an uncountable number of tiny primordial black holes could have held the universe in a kind of stasis. The authors say the resulting stasis epoch would have wide-ranging consequences, including implications for inflationary observables, the stochastic gravitational wave background, baryogenesis, and the production of dark matter and dark radiation. What happens when you get too close to a black hole? Hawking's book A Brief History of Time describes what would happen if an astronaut were to cross a black hole's event horizon, the point of no return, beyond which nothing, except, of course, Hawking radiation, can escape. He uses the phrase, stretched like spaghetti, which is where we got the term, spaghettified. But black holes aren't limited to making spaghetti. Just as gravity close to a black hole can stretch things out, it can also smash things flat, like a pancake. This phenomenon, known as pancake detonation, primarily happens with supermassive black holes. In a pancake detonation, a star that ventures too close to a black hole is flattened and compressed by tidal forces. According to NASA experts, this brief, violent smush is followed by an explosive release of thermonuclear energy. How big are the biggest black holes? Some true behemoth black holes are tens of billions of times the mass of our Sun. Astronomers recently located a black hole they calculated at 30 billion solar masses. Types of black holes. Astronomers generally divide black holes into three categories according to their mass: stellar mass, supermassive, and intermediate mass. The mass ranges that define each group are approximate, and scientists are always reassessing where the boundaries should be set. Cosmologists suspect a fourth type, primordial black holes formed during the birth of the universe, may also lurk undetected in the cosmos. Stellar. When a star with more than 8 times the Sun's mass runs out of fuel, its core collapses, rebounds, and explodes as a supernova. What's left behind depends on the star's mass before the explosion. If it was near the threshold, it creates a city-sized, superdense neutron star. If it had around 20 times the Sun's mass or more, the star's core collapses into a stellar mass black hole. The masses of these newly born objects can range from a few to hundreds of times the Sun's mass, depending on star's mass when the supernova began. Stellar mass black holes can continue to gain mass through collisions with stars and other black holes. Nearly all the stellar mass black holes observed so far have been found because they're paired with stars. They likely originated as mismatched stars where the more massive one evolved rapidly into a black hole. In some cases, called X-ray binaries, the black hole pulls gas off the star into a disk that heats up enough to produce X-rays. Binaries have revealed around 50 suspected or confirmed stellar mass black holes in the Milky Way, but scientists think there may be as many as 100 million in our galaxy alone. Supermassive. Almost every large galaxy, including our Milky Way, has a supermassive black hole at its center. These monster objects have hundreds of thousands to billions of times the Sun's mass, although some scientists place the lower boundary at tens of thousands. The one at the center of our galaxy, Sagittarius A, pronounced EY star, is 4 million times the mass of the Sun, relatively small compared to those found in some other galaxies. For example, the black hole at the center of galaxy Homburg 15A holds at least 40 billion solar masses. Scientists aren't sure how these monster objects came to be. Observations of distant galaxies show that some supermassive black holes formed in the first billion years after the birth of the universe. It's possible these black holes began with the collapse of supermassive stars in the early universe, which gave them a head start. While their origins are mysterious, scientists know supermassive black holes can grow by feeding on smaller objects, like their stellar mass relatives and neutron stars. They can also merge with other supermassive black holes when galaxies collide. Intermediate. Scientists are puzzled by the size gap between stellar mass and supermassive black holes. They think there should be a continuum of sizes because, over cosmic time, collisions between stellar mass black holes should have created some intermediate mass black holes. These should range from around 100 to hundreds of thousands of times the Sun's mass, or tens of thousands, depending on how supermassive black holes are defined. Scientists are actively hunting for examples of these so-called missing link black holes. Numerous candidates have been identified but have proven difficult to confirm. Primordial. Scientists theorize that primordial black holes formed in the first second after the birth of the universe. In that moment, pockets of hot material may have been dense enough to form black holes, potentially with masses ranging from 100,000 times less than a paperclip to 100,000 times more than the Sun's. Then as the universe quickly expanded and cooled, the conditions for forming black holes this way ended. Now, 13.8 billion years later, scientists haven't yet found definitive proof these primordial black holes ever existed. It's possible, However, that they could have evaporated as the cosmos aged due to quantum mechanical processes occurring at the edges of their event horizons. According to theoretical predictions, lower mass black holes, those with less mass than a mountain, would evaporate more quickly than larger ones, which could mean many of these early black holes have completely dissipated. But more massive primordial black holes could still linger across the universe. Anatomy of a black hole. From stellar mass black holes with a few times our Sun's mass to supermassive monsters weighing up to billions more, black holes' makeup is essentially identical. As weird as black holes seem, they possess only three properties: mass, spin, and electrical charge. Event horizon. This is what makes a black hole black. We can think of the event horizon as the black hole's surface. Inside this boundary, the velocity needed to escape the black hole exceeds the speed of light, which is as fast as anything can go. So whatever passes into the event horizon is doomed to stay inside it, even light. Because light can't escape, black holes themselves neither emit nor reflect it, and nothing about what happens within them can reach an outside observer. But astronomers can observe black holes thanks to light emitted by surrounding matter that hasn't yet dipped into the event horizon. Don't forget to like, comment, and subscribe to our channel for more mind-expanding adventures into the realm of science and space exploration.